Hi, I'm Daniele Tavernari, and I have just finished my PhD in Giovanni Ciriello's group at the University of Lausanne. So in this study, we investigated the molecular features of histologic intra-tumor heterogeneity in lung adenocarcinoma. In fact, lung adenocarcinoma shows different histologic patterns of tumor and immune cells appearing even within the same tumor, one next to the other. And in the clinic, it has been shown that the prevalence of this pattern is associated with patient prognosis, with the solid pattern harboring worse survival rates than the lipidic pattern. Now, to investigate the molecular features of these patterns, we performed histopathology-guided multi-region samplings. In other words, we sampled different regions from the same tumor in a way that each of them was coming purely from one of the cell patterns. And finally, we performed several molecular assays to investigate their features. First, we found that patterns were not associated with different genetic insults, but rather exhibited remarkably different transcriptomic profiles, mapping to biological processes related to tumor cells and to immune cells. So, to investigate the cancer cell intrinsic properties of patterns, we leveraged a publicly available single-cell RNA-seq dataset. And we performed the differential expression analysis between the lipidic and the solid pattern, restricting ourselves to genes specifically expressed by tumor cells, thus getting rid of the signal from the tumor microenvironment. So we found that this transition from lipidic to solid was driven by cell dedifferentiation features and increased cell proliferation in the solid pattern. Now, this lipidic to solid signature could be validated in an independent dataset, such as the TCGA, and showed an independent prognostic value in the sense that tumors annotated as solid-like with our signature had a significantly worse survival than lipidic-like tumors in multiple different data sets. Then we moved to investigate the association between patterns and the immune microenvironment. So we found, as predicted by the RNA-seq analysis, that advanced patterns such as acinar and solid had a higher immune cell infiltration with respect to the lipidic pattern, to the lenient initial pattern. This feature could also be seen within the same tumor. You can see here an example where these lipidic regions were immune depleted with respect to these other acinar regions that were immune rich. We also observed that the relationship between tumor and immune cells in situ was different in the various patterns. In particular, we found that the solid pattern harbored a significantly lower co-localization between tumor and immune cells with respect to the other patterns. And this was especially due to the fact that immune cells were mostly kept at the periphery of the solid pattern and were unable to penetrate its depth, thus suggesting that the solid pattern undergoes immune cell exclusion. To probe this further, we performed a spatially resolved proteomic assay, such as the digital spatial profiling, to measure the expression of several immune cell markers in the core and in the periphery of the solid pattern. We found that the immune cells that were still able to penetrate the core were enriched for markers of regulatory T cells, such as CD25 and the FOXP3, and of markers of T cell exhaustion, such as TIM3 and VISTA, thus suggesting that the core of the solid pattern undergoes also immune evasion. So in summary, the pattern progression is characterized by tumor cell dedifferentiation and increased proliferation when going from the lipidic to the most aggressive solid pattern, and on the other hand, by an increase of immune cell infiltration from the lipidic to the acinar and especially to the solid pattern, which also exhibits features of immune evasion. So if you want to read the full story, it has just been published on Cancer Discovery. Thank you for listening.